Welcome, everybody. Thank you so much for joining us once again for Pace AI's foundational AI course for educators. My name is Joe Marquez, and I am here to help guide you through Lesson 3 of Pace AI's course. Now, Lesson 3, what is a large language model? Now, you may have heard this term thrown around quite a bit during the last 18 months, also known as an LLM. You see, a large language model is another subset of AI that uses massive amounts of data to generate text in a conversational style. And they grab this data from many different sources to help train the model on how humans speak. So they have grabbed data from the internet, from books, from online forums. They've also grabbed it from Wikipedia because, like everything, you got to have a little bit of Wikipedia in your life. And through this data, it helps to train the model on how humans interact and respond to questions, to prompts. And one of the most famous of these models is ChatGPT. In fact, that GPT stands for General Pre-trained Transformer. It's been pre-trained with massive amounts of data. Just like we learned in Lesson 2 about machine learning, these large language models learn from massive amounts of data. And the Transformer model takes the prompt you have given, what you are asking, and it uses that plus the data to give a natural language answer to your prompt. That's the output, right? In fact, funny enough, one of the first transformers created, one of the first large language models created was named Bert, just like Bert and Ernie from Sesame Street. And that's what that T in Bert stands for. So there's another large language model called Claude. And so maybe, if we're keeping with the transformer nomenclature, maybe we should change it to Claudette. Maybe we'll reach out to Anthropic and see if they can do that there. But you see, the great thing about this is that it takes our information, our writings, our questions, our responses, our interactions that we've been giving the internet, we've been giving libraries, we've been giving databases for years, and trains itself on how to answer questions, how to provide outputs that humans want. And that is absolutely fascinating. But all of this can create, again, fear, which seems to be a common theme whenever we're talking about machine learning or large language models or AI in general. But I want you to look at this picture, and I want you to see how beautiful it is, because this image is generative AI in a nutshell. You see, Superman, off to the left-hand side, is not from Earth. He is an alien. Spoiler alert. He is from the planet Krypton, and Krypton was about to explode. And his loving father didn't want his son to die. So he built a space crib, placed his son, Kal-El, into that space crib and was going to shoot him off to Earth. But he didn't want him to go to Earth without any information, without any learning, right? And so what his father did, Jor-El, he took a crystal. And in that crystal, he programmed it. He fed it with all the information that the planet Krypton had to offer. All the literature, all the poetry, all the movies, all the TV shows. I would assume Krypton had TV shows. Everything that he can get his hands on, even family diaries, even family movies, every single thing that his father could possibly fit into that crystal was put into the crystal. And he put that in the space crib with Superman, shot him off to Earth. And when Superman became of age, he threw the crystal and it formed the Fortress of Solitude. And when the Fortress of Solitude was created, his father appeared. And Superman was able to ask his father questions, and his father was able to respond to him. But here's the catch. That is not Superman's father. His father died on Krypton when it blew up many, many years ago. What Superman is talking to is a generative replication of his father. The face and body of his father was generated based upon images fed to the crystal. The voice of his father was generated based upon voice recordings that his father gave the crystal. And the response to all of Superman's questions were generated based upon all the data that was fed into the crystal. You see, his father is not giving pre-recorded lines to his son. His father is replying to his son. The input would be Superman's question. The hidden layers of the large language model would be right there in the crystal. And then the output would be the image, the voice, and the response of the newly generated father that Superman is talking to. This is generative AI. This is the beauty of large language models. So how do these models work, right? Again, these models are fed massive amounts of data. And this data is then organized into what the AI sees as patterns. So if this question is asked, then this is an area that it would be looking at, or if this question is asked, this is another area that it would be looking for. And even though this is a very simplistic example, it creates a prediction based upon your prompt, based upon your question, to give you an answer that it believes based on prediction that you'll want. For example, what is a popular small dog breed? Now, there's lots of small dog breeds out there, but based upon the data, it may have a 55% prediction that you're going to want the answer Chihuahua. And then there's a 40% prediction that it's going to be a Shih Tzu, right? So maybe for one person, it'll give the answer Chihuahua, and for another one, it'll give a Shih Tzu. Maybe it'll take some more information that you have in your question to help tilt the scale a little bit more on answering Chihuahua versus Shih Tzu. Right? So this is how these large language models work. It tries to finish your sentence, just like predictive text on your phone, but at a much more massive scale. And because of this, because people are going to ask questions in different ways, because we don't necessarily know how those hidden layers work, I can ask the same exact question 2 times in a row and get very different responses. It may be the same answer of a Chihuahua, but the way they respond will be a little bit different than a way it responds in another way. That's the fascinating thing about these large language models. They present a unique response nearly every time. And we can't necessarily ourselves predict how they are going to respond to a question. Now, of course, there's so much more that goes into how a large language model works than what we're giving you. We're giving you a very simplistic example of how this works. And because there's so much complicated math involved, there's so much going on under the hood that even data scientists who help build these large language models, that they don't understand, that we're just trying to give you a very simplistic understanding of how these large language models work. That is why it's so important in learning how to ask what you want these machines to do. That is why it is so important that we train ourselves and students into becoming the best prompt engineers that they possibly can be. Now, what that means is they need to know the nuances of asking a question. They need to know the vocabulary of the topic they're trying to ask a question of. They need to be linguistically accurate in asking these large language models for something they want to come out of it. That's all with prompt engineering. And what that means is you need to have a purpose when going into these devices. You need to have a purpose when asking these devices what to do. You need to have a plan for using AI. And that's why I've come up with AI cubed. That's artificial intelligence intentional inclusion. You need to have an intentional reason to include AI in your educational process. And so do your students. So you need to ask yourself, why am I using AI? What am I going to ask it? How am I going to ask it? Every plan needs to have a beginning. So every time you use AI, you need to have a plan on how you are going to ask it to use it. And my advice to you on prompt engineering is this. Prompt engineering is a difficult skill because of the black box of the large language models. And it takes not only practice, but patience. And the best way to learn how to prompt, right, is to take the time to think about what you want the AI to do. And once you have a grasp of what you want the AI to do, you should be able to craft a prompt with the right context to ask those questions. We should never prompt like we're Googling, right? Like, what is this? We should never prompt with like a 4-word sentence. We should prompt like we're writing a paragraph. And that takes time. That's why we have a checklist for prompt engineering, right? And we should always include a task. What do we want this large language model to do? We need to provide it with as much context as possible. For example, if you are asking it to help you write a lesson plan, what grade level, what subject, how many times a week do you meet? How often do you meet? How long do you meet? All of this context is key to feed the large language model with enough information to give you a better output. Maybe include an example. Maybe you have a rubric. That's the example or the exemplar that we're going to be looking there. And then you can also ask for it to change its persona. You are an expert in writing lesson plans or in a format. Please make sure the format is in bullet points or tone and style. This is for my students, so please only use 8th grade vocabulary, right, in that tone or style. This is just a checklist for how to craft a successful prompt. But there is no answer to how to write a best prompt. It just takes time, practice, and persistence. And then finally, fine-tuning. What is fine-tuning? Well, fine-tuning is a technique that is used for using large language models for a very specific case. For example, we are starting to see large language models being fine-tuned for specific industries, such as large language models being fine-tuned to be used in law firms, large language models to be used in healthcare, large language models to be used in education. Fine-tuning adds specifics and more customized data for specific use cases. But you can also refine your prompts to help fine-tune how you want that output to come in by narrowing in on exactly what you're asking it to do. Such as, I am an educator, and you will be helping me craft a lesson plan. You are helping that with your language, right? And so these are things that we have to think about when we are asking our large language models, when we're asking our AI to better assist us with our tasks. There's a whole lot of AI out there. There's not one singular tool that will do everything for you. So the one thing that we would recommend, go out there and explore. Go out there and play. Find the tools that best fit and meet your needs for the task you are trying to have it meet. Thank you so much for joining us for this lesson. We cannot wait to see you for our next one. Have yourselves a wonderful, wonderful day.